What's up, everybody? Today we are going to be looking at a system of equations with three variables, and we're going to be using substitution to solve it. The first step I'm going to take is I'm going to number my three equations I am beginning with, and then I'm going to look for something that I can substitute into one of the other equations. I see very quickly that z is equal to negative 3x minus 1, and thus I am going to take the negative 3x minus 1 and substitute it into z in the first equation. At this point, I have used equations 1 and 2, and what I'm going to do is I'm going to simplify those two equations. So first I distribute the negative 3, and I end up with a positive 9x plus 3 equal to negative 9, along with the negative x minus y in the front. Now I'm going to add my like terms, and I end up with 8x minus y equal to negative 12. I'm going to solve for y because I want to get this in terms of x. I want to get the same thing there. I'm going to get y equal to 8x plus 12. Now if we look up here at the 8x minus y equal to 12, we can stop there, and then we can look at the z and see we already have it in terms of x, and that's how we decided to solve for y here. There are going to be times where you will have to substitute another time in order to find what you can make all, which variable you can make all the same. Our next step here is to take our original number 2, and we have to substitute it into the equation that we have not used yet, which is equation 3, because we need to use all three equations. We substitute it in here for the z, and we have negative 3x minus 1 inside of the minus here. And before we do anything else, since we've solved for y, we can also put that in terms of x. So you can see we have taken our equation 4 and substituted it in to equation 3, and we've taken equation 2 and substituted it into equation 3. At this point, we're going to simplify. When we combine our like terms, we end up with 40x plus 60 plus 3x plus 1 equal to 23. If you subtract the x from the left side over and add the 40x and the 3x, you end up with 42x. If you take the 60, the 1, and the 23 and combine them, you end up with 84, and you subtract it to be on the opposite side of the x. When we divide, x ends up equaling negative 2. At this point, we are going to go back up to our original equations, and we are going to substitute. We see that in equation 2, we have just an x and a z. So if I put negative 2 in right here for x, I get negative 3 times negative 2 is positive 6. 6 minus 1 is 5. So z is equal to 5. Now I can choose at this point to do a couple, or to substitute both the z equals 5 and the x equals negative 2 into one of the original equations, or I can take x and substitute it into equation 4 here. If I take 8 times negative 2, I get negative 16 plus 12. And negative 16 plus 12 is negative 4. So I end up with x as negative 2, z as 5, and y as negative 4. I'm going to move those around to alphabetical order and rewrite my solution as negative 2, negative 4, and 5. Thank you very much for your time.